Alrighty, so as we were plotting our points, writing down our table, we have -3, -5.4, we have -2, and -2.4, -1, -0.6. If you arrow down on your table, on your calculator, we have 0, 0. And then you'll notice our numbers begin repeating, only with the positive x values. +1, but still -0.6. I have +2 with -2.4. +3 with -5.4. And finally, I have +4 with -9.6. So we're going to plot all of those values, all of those coordinate points on our coordinate plane. So here's my x-axis, my y-axis. Let's plot. To the left, 4 units, 1, 2, 3, 4, and down almost 10 full units, so down 9.5 units. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. Second point, -3 to the left and -5.4. So that's about 5.5 units down. 1, 2, 3 to the left. 1, 2, 3, 4, 5.5 units. Third point, -2, -2.4, so about -2.5. So -2 to the left and -2.5 down. We have -1 to the left and -0.6, so about halfway down. 0, 0. And now let's plot our points to the right. So to the right 1, down about half of a unit. To the right 2, down about 2.5 units. To the right 3, down about 5.5 units. To the right 4, and down about 9.5 units. Great. So let's plot our points and connect our points. And we see that this quadratic is a little bit wider. And we're going to learn in future lessons as to why it is wider. But just like we said at the beginning, this negative right here changes the direction of our parabola, so it opens downward, and it sure did. We see our graph. Okay, so I want you to stop the video, and I want you to attempt to do number 5 on your own using your graphing calculator. Make a t-table, plot your points. And number 6 on your own using your graphing calculator, make a t-table and plot your points. And then we'll talk about number 7. Bring it to me if you get stuck for number 5 or number 6, and I'll check your work. Okay, let's look at problem number 7. In this problem, we're going to order each group of quadratic functions from the widest to the most narrow. So in order to do that, we just need a simple understanding of what is going on. So here, the rule is, look at the A value. So I'm not looking if the A is positive or negative. I'm actually looking at the absolute value of A. Not positive, not negative, just the number itself. So the bigger that number is, the more narrow our graph is going to become. The smaller that number is, the closer to 0 that number is, the more wide it's going to become. So we can say two things. the further away from 0, further away from 0 equals more narrow. The closer that absolute value number is of A, the more wide it becomes. All right. So let's look at problem number 7. In problem number 7, we see we have a 2, a 4, and a 3. And so when I do these problems, I make just a simple little chart on my paper. And my chart looks like this. It says W for the most wide, N for the most narrow, and whatever is in the middle between them is M for whatever is in the middle between them. All right, we said the most wide is a number closer to 0. So 2, 4, and 3. Which one of those 3 numbers is the closest to 0? Well, the 2. So y equals negative 2x squared. Which number is the furthest away from 0? The 4. It is the largest. So the most narrow will be y equals negative 4x squared. That only leaves us with one other option for what's in the middle. So that gives us y equals negative 3x squared for what goes in the middle. A great way to check these is using your graphing calculator, and that way you'll get a nice visual picture to tell you if you have learned the rule and applied it correctly. So let's write ourselves a note. Check on a graph in the calculator. Okay, so right now I want you to pause the video and go to number 8 on your own. You can do number 8 using the rule applied here and then check it in the graphing calculator. Come and talk to me and make sure that you did it correctly. And if you're stuck, I'll help you out. All right, one last problem here on this lesson. We're going to do our word application problem, and we're going to discuss Jared. So Jared is casting his fishing line with a lead sinker. I don't know if you've been fishing, but sinkers are important so your line doesn't float. And it's attached over the edges of a pier. So the pier is 15 feet above the water. And we have a function. Let's underline our function. Circle, highlight, box, star, underline our function. Whenever they give you a function, it's going to be used for something important every time. And that gives the sinker's height above the water in feet after so many t seconds. Our job is to graph. We're going to graph this particular function. We're also going to have to answer a question. After how many seconds does it take for the sinker to hit the water? Oh, and we're going to use inequalities to describe a reasonable domain and range. We haven't talked about domain and range today, so we're going to look at those now. All right. So we have our function. And to type this in a calculator, this would be f of x equals negative 16x squared plus 15. So I've taken out the h and the t, and I've put f of x and x into our function. So now that I have this, let's go turn on your calculator, and we're going to graph it to look at it. So let's push Control Dock and go to a new graph. Here in my graph, let's type our function, negative 16x squared plus 15. Enter. And there's my parabola. Now, you know, just from common sense, you can only cast a fishing line one direction. And time is always positive. It always marches forward. We're not Barry Allen. We're not the Flash. We cannot go back in time. So we can only look at the right side of your coordinate plane. And that means we're going to look from time 0 to quite possibly just a point value of 1. So let's go look over at the plane on our paper. Here is x, here is y, and this is going to be our time in seconds. It's important to label your graph. And then this will be our y-axis. It'll be our height above the water. That'll be in feet.